So, the topic for today is linear regression. So, in
Okay.
linear regression, I'll tell you the agenda. So, firstly, we will see before linear regression. So, we will take an example of a real estate agent who will try to estimate the price of a house. So, he gets
Okay.
lot of deals about selling different houses. So, he has to think about his own commission and also the seller's amount that he has to pay back. So how people used to do without using machine learning versus how machine learning can be used for the same real estate agent. So that is classical approaches without machine learning. Then what are the challenges he might face? Then we will see how he can use linear regression with the intuition. We will then see the code of linear regression for the same house related uh, columns and some practical applications. Now, coming to the classical approach. So, go here. So, imagine uh, the real estate agent has some number of columns as one of the data. So, before coming here, so imagine he got some data which is something like this. So, number of rooms equal to 1, the price of the house is some 150. Similarly, 2, 200, 3, 250, and so on. Now, by looking at this data, can you predict what would be the price of a house which the four number of rooms? Can you give any guesses?
Yeah, I mean, we can use formulas.
Yeah, so the value firstly, what it might be considering the past data and the price of the house with rooms 5, 6, 7. Can you see what value you can fill up here?
Uh, like for one room, it's 150.
Hmm.
Maybe we can take like average. 1 second, let me guess.
Uh, Seeing the pattern,
300.
right? So for four rooms, it will be 300.
Yeah,
The Here the data is uniform, which is it is increasing in a uniform fashion. It is
yeah.
the formula finally. If I ask you a equation of a line formula, which is y equal to mx plus c, it will be like 100 plus 50 into 1. See, 100 plus 50 into 1 is 100 plus 50, 150. 100 plus 50 into 2, 200. So this is how a real estate agent can come up with a price given the number of rooms. But in reality, the data will be not so straightforward. So here when we plot the data, this is how the data that I showed you, which is in a uniform way, will look like. So
Mhm.
if the data will be something similar, what he can do is he can draw a line and the line can keep extending based on the number of rooms in a house. So whenever a new house comes up, he can look at what is the number of rooms and he can check the respective y-axis value. He can say that will be the price of the house which he will quote for the customer. So here I have built a linear regression model which will do the same. So I'll show you the model code. So these two lines are for creating model variable. Here you are doing model.fit, passing two variables, number of rooms and price.
Okay.
Here I have wantedly removed the data where we have the missing value, number of rooms equal to 4.
Okay.
Then now after, so here we can see this is the intercept form, this is the slope form coefficient. So y
Okay.
equal to mx plus c equation which I told you.
Mm.
Now when I want to predict for any new rooms, you pass the value number of rooms equal to 4, you will get. So model dot predict. SLR is nothing but the model variable which we created above here.
Okay.
But in reality, data will be not straightforward. So it can be something like this. So earlier the points were diagonally uniform, but in reality, data can be scattered. So the way linear regression works to come up with the best line, which will give us the best prediction given the number of rooms in future. So firstly, what he can do is, if the data is straightforward, simply apply this y equal to mx plus c formula. But the challenge with traditional approaches, data will be not straightforward. It will be jumbled. For example, one rooms earlier it was 150, 200, 250, so on. But it will be not straightforward. Hence, you cannot use a formula as it is.
Mm.
Then the best thing that you can do is use a linear regression. Here is when the linear regression comes into picture, wherein the firstly it will plot the points. This is how the data looks like. Then
Okay.
now here you can imagine, let's say this is the final line, but before it comes up with this final line, these are the points. The way it comes up with the final line is, it can draw a first line something like this horizontally, or something like this, or a line that starts nearby this first point but can go something straight like this. There are n number of possibilities, but the way it comes up with this final line is, it uses a optimization technique called as gradient descent, wherein I will show you how it comes up. So this is the original point, this is the final line. So what it does, this is the original point, but let's say here we have a number of rooms is 1. Rather than saying this is the price that we can quote, it will tell the value on the line. See, this is how much we can quote. So there is some error between the actual value and the line, the, the value which the line is giving. So here you can see y is nothing but, I'll just zoom in. So here y is nothing but the actual value. Y dash is nothing but the value which the line is giving. So when you subtract both, you will get some error which this model is giving. So it will calculate the error of all the points with respect to the line, the prediction value. It will try to minimize that error. So this value, error value, it will try to minimize. It will draw multiple lines internally, find the best line by minimizing that error. So this is how the linear regression intuition is, tries to minimize that error. And the final equation that it comes up with is y equal to, so in our case it is 50 plus 100 plus 50 into x. So 50 is our slope. uh, Here 100 is our slope. One second, let me look at the data. Yeah, so 100 plus 50 into x. So this is our intercept for value, this is our slope value, 100 plus 50 into x. The way it comes up with this 100 is the line where it touches the y-axis value. So in our case, if I have to show you, the final line that comes up with will look like, so imagine a value 100. It will be like a line passing y-axis. So this value is 100. So that's what we mean by 100 plus y, 50 plus c.
Okay.
And then code part. Code part, like I showed you. Now when you try to uh, do the same coding on this random values, which is like, we can think of some real-time values which is not exactly uniform. Here now, earlier we got for 4 rooms it is 300, but now
Yeah.
it is 301. So this is also not a great practical applications of linear regression. The linear regression application comes into picture when, so we simply won't predict the price of a house based on number of rooms. There are n number of lot other uh, data that we use. The locality of the house, the SFT of the house. Similarly, maybe the current prices, etc., etc. Lot of other things. The age of the building. So when you try to, as a human using classical programming, try to predict the price of the house using two columns, it is straightforward. Maybe you can draw a line, you can predict accordingly. But when there comes the picture, when you have to use n number of other features, you cannot do it manually. That is when machine learning comes into picture. And here, rather than passing one column apart from the price column, you can pass a list of columns, and the model will uh, not here while drawing the scatter plot, while doing the modeling part, that is here. So while doing model.fit, you can pass n number of other columns along with the price column. Model will learn the patterns by itself, and you can pass the list of values here while doing the predict. It will give the price accordingly. Finally, coming to the applications. So applications of linear regression can be predicting any. So basically, the goal of linear regression is to find a relation between the independent features. Independent features are the columns that we are using to predict the price of the house, like age of the building, number of rooms, etc. The goal is to use this independent variables to predict a dependent variable, which in our case is the price of the house. So here other examples, predicting the lifespan of a patient based on the current health condition. More, how many years he could be alive. Similar, so lifespan is nothing but the number of years he can be alive going forward. Hence, we can use regression here. Similarly, predicting the length of hospital stay based on current symptoms. So these are the some of the applications. So do you have any doubts here until now? What all we discussed so far?
No, it's clear.
Okay, thank you.